Hello students, today we are going to continue with laws of motion. So we are going to cover these following topics. Basically we are going to cover the graphs today. We are going to cover 4 graphs: distance time graph for uniform motion, distance and time graph for non-uniform motion, velocity time graph for uniform velocity, and velocity time graph for uniform acceleration or non-uniform velocity, uniform acceleration, positive, negative, and zero acceleration. So we are going to begin with distance time graph for uniform motion. Suppose there is a bus which is traveling 15 meters in every 10 seconds. So at 10 seconds, it's a distance of 15 meter. At 20 seconds, it is at a distance of 30 meters. At 30 seconds, it's a distance of 45 meters. So in every 10 seconds, it covers a constant distance of 15 meters. So the bus is covering equal distances in equal intervals of time. So if we plot a graph between distance and time, we see that this graph is a straight line. So distance is directly proportional to time. This is called uniform motion. When an object covers equal distances in equal intervals of time, we say it is moving with uniform motion. Now, can you tell me what is the slope of this graph? What is the slope of this line? No, so we know that we can draw a slope like this. We can so this is 30, 30, and this is 45. So this is y2 and final position. This is y1 initial position. This is x1 initial time and x2 final time. So we know that slope is equal to y2 minus y1 upon x2 minus x1. We have studied this in maths. So this is nothing but 45 minus 30 upon 30 minus 20. So this is 15 upon 10, which is 1.5. Now this is nothing but distance, change in distance upon change in time. Change in distance with respect to time. So this is nothing but 1.5 meter per second, which is nothing but velocity, speed. So this slope of distance time graph gives us velocity. Now let's move on to our next topic. Non-uniform motion. If the object covers unequal distances in equal intervals of time, we say it is moving with non-uniform motion. See, the distances are not constant. It is changing unequally. So, at 15 seconds, it has covered 20 meters. At 20 seconds, it has covered 30 meters. But at 25 seconds, it has covered 41 meters. So, the graph is not a straight line between distance and time. This is a curved line. So distance is not directly proportional to time. This is nothing but non-uniform motion. So when an object covers unequal distances in equal intervals of time, we say that the object is moving with non-uniform motion. So again, the slope of this graph will again be the same, which is nothing but velocity or speed. Now let's move on to our next topic, but before that we will see how much we have covered now. So we have covered distance time graph for uniform motion. We have covered distance time graph for non-uniform motion. Now let's move on to our next topic, which is velocity time graph for uniform velocity. See, if the object is moving, it might be having some speed. So we are going to cover velocity time graph. Earlier in earlier two graphs, we have taken distance time. Now we are going to take velocity time. So if an object is moving with a constant velocity or uniform velocity, that is at every 10 hours, if we see this table, in every 10 hours, the train is traveling at a speed of 60 km per hour. After 30 hours, again it is moving at the speed of 60 km per hour. Again at the interval of 40 hours, it is again moving with the speed of 60 km per hour. So it is moving with a constant velocity or a uniform velocity. So if we draw a graph between velocity and time, where we plot velocity on y-axis and time on x-axis, it is moving with a constant speed of 60 km per hour. So the velocity, this line is parallel to x-axis. Now can you tell me what is the distance? We know velocity into time is distance. We have covered this. So velocity is how much? If we say we have to find out the distance from A and B. When the object traveled from A to B, we have to find out how much distance it has traveled. And we are given velocity and we are given time. So we know that velocity into time is distance. So velocity is how much? It is 60. At C, the velocity is 60. At D, the velocity is 60. So average velocity is 60. And time is how much? 10. 30 minus 20. So that is equal to distance, which is 600 kilometers. Now, can you tell me, this is a quadrangle ABDC. So what is the area of this quadrangle? Area of ABDC. This is nothing but area of rectangle ABDC, which is nothing but length into breadth. So length is how much? 10. 30 minus 20, 10. And breadth is how much? We can say 60. Or we can say this is how much? 600 kilometers. So the length was 60, the breadth was 10, which is the area of rectangle ABDC, which is 600 kilometers. So this is nothing but distance covered. So area of quadrangle ABCD is going to give us the distance covered by train in this velocity time graph. Now can you tell me what is the acceleration of the train? Acceleration of the train is nothing but 0. How? This is change in velocity upon change in with respect to time. So change in velocity is 0. It was at 60 km per hour at C, and again it is at 60 km per hour at D. So acceleration is 0. So when a body is moving with uniform velocity or a constant velocity with respect to time, we say it is moving with 0 acceleration. This was a uniform velocity graph. Now what if the body is not moving with uniform velocity but with a changing velocity? So here we have this example of uniform acceleration. When the velocity of an object increases with respect to time, we say that the object is moving with uniform acceleration. So here we have taken the example of train. The train is moving with increasing velocity. At 5 hours it is moving with 8 km per hour. At 10 hours it is moving with 16 km per hour. At 15 hours it is moving with 24 km per hour. So we find there is an increase of 8 km per hour in every 5 hours. So if we plot a graph between velocity and time, where velocity increases with time, we say that this is uniform acceleration. The velocity is changing with time. If the velocity increases by equal amounts in equal intervals of time, we say it is moving with uniform acceleration. When there is velocity changes in equal amounts in equal intervals of time, we say that the body is moving with in equal intervals of time, we say that the body is moving with uniform acceleration. But what if the velocity increases with increase in time? We say it is positive acceleration. If the velocity decreases with time, we say it is negative acceleration or retardation. So this is an example of retardation where we can say that the velocity is decreasing with respect to time. The velocity of an object is decreasing with respect to time. It is called negative acceleration or retardation, whereas this line is positive acceleration. So the direction of positive acceleration is that of the velocity, whereas the direction of the negative acceleration or deceleration is opposite to the direction of velocity. This is velocity. So if the body is moving with a constant velocity or uniform velocity, we say it has zero acceleration. So now what if we want to know what is the distance covered by this train from ten to 20 hours. We have to find out the distance covered by train when it traveled from A to B. So we know that velocity is distance upon time. So distance is how much? Distance covered will be velocity into time. Average velocity will be 32 plus 16. See, the velocity at C is 32 km per hour. Velocity at E is 16 km per hour. So we have to take average of this velocity into time taken, which is 20 minus 10, which is 10. So this comes out to be 48 by 2 into 10, which is nothing but 240 km per hour. So the distance covered by this train is 240 kilometers, not per hour, that will be velocity. So now, if we have to find out the distance from this quadrangle, we know that the area of the quadrangle, we saw it in the previous example that the area of the quadrangle represents distance. So we can say without using the formula of distance and velocity, we can say area of triangle EDC plus area of rectangle ABDE is the area of quadrangle ABCE. This is nothing but half into 10 into 16 minus 32 will be 16 plus area of rectangle ABD is nothing but length into breadth, which is 10 into 16. AT plus 160, which is again 240 kilometers. So we know now that the area of a graph, of velocity time graph, will give us distance. The slope of distance time graph or slope of any line will give us, so slope of velocity time graph will give us acceleration, but the area of this quadrangle will give us distance. So we will now move on to our next topic in our next session. Till then, goodbye. Bye bye.